Okay, so as the semester comes to a close, our final project, we've covered a number of different topics over the past semester. However, two topics in particular have important real world applications that I think often get overlooked, and that is Newton's law of heating and cooling and improper integrals for Module 5 and Module 1. So, in Module 5, we learned that some quantities change at a rate proportional to the difference between the existing amount of that quantity and some fixed constant b. Frequently, these problems are related to Newton's law of heating and cooling. So Newton's law of heating and cooling, as we know, is dy dt is equal to k times y minus b. And there are a plethora of different applications of Newton's law of heating and cooling outside of the classroom that often get overlooked that I never thought about until this class. So let's take a look at those. So Newton's law of heating and cooling can be used to find the amount of time needed for a hot cup of tea to reach a certain temperature. It can also be used to find the temperature of a soda after being poured into a glass over a certain period or amount of time. It can also be used at a crime scene. It's used at crime scenes to give the time of death of a dead person, given the body temperature and the probable body temperature at the time of death. So there are a lot of real-world applications. It's also used for the temperature of a casserole at a certain amount of time. So let's look at that and let's do a practice problem. Okay, let's move to example number 2. Suppose a casserole is removed from an oven that is 250 degrees Fahrenheit and is placed in a room that is 72 degrees. After 1 hour, the casserole is 200 degrees Fahrenheit. What is the temperature of the casserole after 90 minutes? Okay, so you're going to use the basic equation for Newton's law, or the Newton's law differential equation of heating and cooling, which is dy dt is equal to k times y minus b. And so we know that the constant temperature in the room is 72 degrees Fahrenheit, so that's going to take the place of our b. And then we're just going to solve for y as we did in the previous problem, from calculus AB. And when you solve for y, you get y equals a times e raised to the kt plus 72. And if you dissect the word problem, the oven, it is 250 degrees. And so we can assume that the temperature of our casserole at time t equals 0 is going to be the same temperature as the oven, which is 250 degrees. So we can solve for our constant a. So when you set t equals to 0 and you set your equation equal to 250, you solve a to be 178. However, we're not done yet. We now have y is equal to 178 e raised to the kt plus 72, but we need to solve for k. So we're going to use the other bit of information that's given to us, which is the temperature of the casserole after 60 minutes. So you plug in 60 for t and you set it equal to 200, and when you solve, you get k is equal to negative 0.005495881. And then you can plug this in and you have your full-fledged equation, and you can solve for the temperature of the casserole at t equals 90 degrees. Probably wondering, are there any careers that utilize Newton's law of heating and cooling? Which is a good question. There are. Forensics experts actually use this law. Forensics is the use of scientific tests and techniques used in the field of detection for crime scenes. But forensics experts, more specifically, are like expert witnesses. They testify or give forensics-related opinions at a trial or hearing per their specialized knowledge, and a lot of times they're paid to fly out to big hearings. Forensics experts use this law to discover when the victims of crimes died, so they use Newton's law to discover that. So actually, by knowing the average temperature of the human body, which is 98.6 degrees Fahrenheit, and measuring both the room temperature and the temperature of the body when found, forensics experts can solve for K and T. So if you really think about it, forensics experts can use Newton's law of heating and cooling in murder trials and in court to help catch criminals, which is pretty cool to think about. Okay, so let's move on to Module 1, where we learned about improper integrals, which was quite a while ago. But improper integrals are just like definite integrals, except they cover an unbounded area. That's kind of like a recap. So you may be asking yourself right now, what real-world applications do improper integrals have? Well, more than you would think. I was very surprised. Some real-world applications include probability, and statistics, which is probably the big overarching one. So improper integrals are used in probability and statistics to model quantities by probability distribution. An example of a probability distribution would be the normal distribution curve, which is also, or the normal distribution, which is known as the bell curve. For example, to calculate the probability that the quantity is above a fixed number n, one would actually use an integral of the probability distribution function from n to infinity, which, as we know by the definition, is an improper integral. So, but moving along, you're probably wondering again, can improper integrals be used in any careers? The answer, once again, is yes, surprisingly. So a statistician is the most common career, but a statistician works with theoretical or applied statistics, collecting, analyzing, and interpreting data. They can work in both the private and public sectors of the economy. But there are also a number of other job titles that fall under this category that many don't think about, such as actuaries, who analyze the financial consequences of risk, quantitative psychologists, who use statistical analysis to study human attributes, and financial analysts, who use economics to make business recommendations. So these careers all use improper integrals as a subset of statistics to analyze data, which is interesting because a lot of people like to separate statistics and calculus, but they actually converge in certain aspects and areas, and this is one of those regards where they converge. So in all of the aforementioned careers, improper integrals are used to evaluate the risk of certain business decisions in the context of statistics by looking at how a certain set of numbers lie on a normal curve. So as you can see, calculus is around us in ways that we've never even imagined before. At least I know for me. And we can take all that we've learned this year and apply it to the world around us. So thank you for a fantastic semester. I've learned a lot. And thanks for watching.